We have some steps we need to follow. The first thing is isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. Raise each side of the equation to a power equal to the index. Remember, the index is this value that's in the crook right here. That this one is a square root, so it's understood to be a 2. Third, solve the resulting equation. If the equation still has a radical, we've got to go back to step 1 and do that all over again until we get to a point where we have no radicals. Check the potential solutions in the original equation and write the solution set. In solving radical equations, extraneous solutions potentially arise when both sides of the equation are raised to an even power. Therefore, an equation with only odd index roots will not have extraneous solutions. However, it's still recommended that you check all potential solutions. So, number 9. We're going to solve this equation, and step 1 said I needed to isolate the radical. Here's my radical, but a 3 is being added. I need to subtract that. Next step, since my radical is isolated, I need to raise both sides up to whatever that index is. And since this is a square root, I'm going to square both sides. So when you take the square of a square root, the radicand is what's left, what's under the radical. Now I need to FOIL this. So you need to go FOIL it and see if you end up with the same thing I do. Now I'm going to end up with a quadratic, so it means all terms need to come over to one side, and I like to keep my x squared positive. Now if you'll pause me, go and factor this, and then unpause me and see if we have the same thing. I'm going to set those individually equal to 0. So those are my possibilities. I need to check. Let's see if I can get this where we can see it. So the first one's a 2. I go back to my original equation. Make sure it looks exactly like it. Now if this works, then this should come out to be a 2, because if you'll notice on this side I have an x. Well, it comes out to be 4. I don't think that works. Let's try 5. 5 storing for x. Second enter, and let's see if this comes out to be 5. It does. So the only one that works here is this one right here. Number 10. I have 2 radicals, and it said if I had more than one, then isolate one. So this one's already isolated. So we're going to go ahead and square both sides, since that's what my index is. This side's nice because all I have is 1 minus 2x. This side, you need to go FOIL. Remember that quantity squared is 2 plus times. If you FOIL that, you have 2 times 2. That will give me a 4. 2 times the outside would be a 2 square root of 1 minus x. 2 times the inside would be another one. So that means I end up with a 4 square root 1 minus x. And then this times this is actually square root of 1 minus x quantity squared. So I just end up with a plus 1 minus x. So I need to simplify to see what I've got right now. I see a 4 and a 1. That'll give me a 5. A minus x plus 4 square root of 1 minus x. Okay, Now what I'm going to do is, since I've got another radical, and it told me earlier that if I've got another one, then I've got to go do the steps all over again. So I'm going to subtract 5, add x, because I want to isolate that piece right there. So subtracting 5 gives me a negative 4. Adding x will give me a minus x. Now if I want to truly isolate this, I'm going to divide both sides by 4. Okay, now I'm going to square both sides. And I always do the easiest side first. This side, we need to square numerator and denominator, so my denominator is going to be 16. I need you to take this binomial and go square it, and then unpause me and then see if we end up with the same thing. I need another sheet of paper. Alright, now I have an equation and I see a fraction, so I'm going to multiply both sides by 16. So that will give me 16 plus 8x plus x squared. And when I multiply by 16 over here, so I've got myself a quadratic. I'm going to move everything over to the left-hand side. If I subtract 16, they eliminate. So I'm going to have x squared. I need to add 16x. This is a binomial. X is a common factor. Set these individually equal to 0. I said individually equal to 0. So x could be 0 or x could be a negative 24. But we need to check this. So since I can now get this a little bit closer, let's go check. Well, poo. 0 storing for x. So I've got square root 1 minus 2x. See what that equals. 2 plus shift square root 1 minus x. And if they come out to be the same, then it works. They don't. You just exit out. Don't go real mental. Just exit out. Now this one is a negative 24. Let's store in for x. I'm going to do second inner, and one more to get to my first one. Now let me do second inner, to get back to the other one. Since they both are 7, then that one does work. So we've got a few more to do. This one. You'll notice it's x to the 2/3 equals 4. So I need to solve for x. If I solve for x, then I need to multiply by the reciprocal of that. You've got to be careful when you multiply by a reciprocal and the denominator is going to be an even number. So let me rewrite this a little bit bigger, because when I multiply by the reciprocal, do you see that even number down there? Technically you're taking square root. That would look like, okay, but when you're doing this, you're taking the square root. So I need to remember to do a plus or minus. The only time I have to do that is if my denominator of my reciprocal is even. So it's just something a little sneaky you got to remember. So if I multiply this, I get x to the first. If I do 4 raised to the 3/2, 4 raised to the 3 divided by 2 is 8. Another way you could look at it is you take the square root of 4, which is 2, and 2 to the 3rd would be 8. But this is a plus or minus 8 because the value in here gets squared. So if it's negative, it's going to change it to a positive. I'm going to check them all. Let me store that in for x. X raised to the 2 divided by 3. There's my 4, so I know the positive works. Let me store the negative version. Second enter, and that one works. So that would be my solution. Again, remember, anytime you're multiplying by the reciprocal of the exponent, and if the denominator is even, use a plus or minus on the other side. Now this one, I'll write it just a little bit bigger. Well, the reciprocal of 1/5 would be 5 over 1. So I'm going to raise it to the 5th power. That gives me x plus 1 is equal to, if you do negative 3 raised to the 5th, negative 3 raised to the 5th. Even if I did it in parentheses, I really should have used parentheses. Because if that were even, then it'd be a different game. So that'd be a negative 243. I'm going to subtract 1. So let me subtract 1. Let me store that answer. And then I'll go back, parentheses, x plus 1 raised to the, you could do 0.2, which is 1/5, or 1 divided by 5. So that one does work. And that's it for this video. Thank you.